Okay, guys, so I don't know what happened with my Notability. Hold on. All right, there we go. So our last set of vocab is congruent arcs, all right? And I want you to pay really close attention to what this one is saying. So congruent arcs are arcs that have the exact same length, all right? And there's a key word in here, which is length, because what we've been talking about so far, all right, is the measure of arcs, okay? So it says arcs that have the exact same length. So what I want to talk about is the difference between the measure of an arc and the length of an arc, okay? So I want you to look at this little circle right here. I'm going to do it in even tinier font size. All right, so here's my little circle, okay? I'm going to go ahead and mark in that center. And I'm going to make a central angle. And let's make that pretty easy and just say that that central angle is 90 degrees. All right, so that's a 90-degree angle. And if you look at the arc that it creates, all right, so let's go ahead and name that arc AB. And so if we look at that arc, okay, that arc measures 90 degrees, all right? So the arc measures 90 degrees, okay? Now what I'm going to do now, though, is I'm going to draw an even bigger circle, okay? And I'm going to again mark in the center, and I'm going to go ahead and make another central angle, okay, that is 90 degrees. And so then the arc that it creates right here, all right, let's call this C and D, all right? And if I highlight C to D here, based off of the central angle theorem, all right, if that arc is 90 degrees, then the measure of this arc CD is also 90 degrees, right? So we know that. Oops. But so the measures are the same in this picture, all right? This measures 90 degrees, this also measures 90 degrees, okay? But what I'm talking about is the length of it. So if you actually look, all right, at the space that's being devoted to that arc versus the space that's being devoted to that arc, the lengths are different, all right? The measures can be the same, but the lengths of those arcs are different, okay? So what that means is that the length of the arc is dependent on how big the circle is, and the size of the circle is dependent on the radius, all right? So in this case, arcs are congruent if they have the same length, not if they have the same measure, okay? So that brings us down to theorem 10.1 that says, in the same circle or in congruent circles, the arcs are congruent if and only if their central angles are congruent, all right? So what that's saying is if we have this circle, all right, and we'll do it in one circle, all right, and I put in my center, and let's draw two diameters that are passing through that center. And the reason why I'm doing that is I'm making vertical angles. Then these two angles have to be congruent, and then if these two angles are congruent, then these two arcs have to have the same length, all right, which means that they're congruent as well, okay? So when we're talking about congruent arcs, we're talking about the length of the arcs, not the measure of the arcs, okay? The measures will be the same, all right, but we're talking about the lengths. So that brings us to our last concept here, all right, which is arc length. So again, all right, I've already talked about this, but the arc length is different than the measure of the arc, and that's what we studied up here, all right? The measures were the same of these two, but the lengths had to be different, okay? And it says that the length is dependent on the radius of the circle. So we have a formula for the arc length, all right? And so that arc length, all right, is going to be given to us in this formula. So what I'm going to do is I'm going to take the measure of an arc, and let's call it AB. So I'm going to take the measure of the arc, and I'm going to divide that by 360. And then I'm going to take that fraction, and I'm going to multiply it times the circumference, which is 2 pi r. So this is equal to the length of an arc. Okay, and again, the length is dependent on the radius, all right, of that circle. So let's go ahead and try that in these two examples. So it says to find the length of arc ZY. All right, so if I look at ZY right here, okay, it says to find the length of it. So my formula is, all right, it's going to be the measure of arc ZY all over 360 times 2 pi r. And we're not going to make it exact because it doesn't say exact, all right? So we are going to make this into a decimal. But the measure of the arc is 75 degrees. So I'm going to do 75 over 360 times 2 times 3.14, because I'm going to use pi to, or 3.14 to represent pi. And then my radius is 4, so times 4. And now I'm just going to plug this into the calculator. So I'm going to do 75 divided by 360. And that gives me 0.2, let's do 0.208 times 2 times 3.14 times 4. And I got 5.23. All right, so 5.23 is going to represent the length of that arc. All right, so 5.23 is going to represent the length of that arc. All right, next one. Again, we're going to try to find the length of arc ZY. All right, so the measure of that arc is 130 degrees. Okay, so let's go ahead and plug into our formula. So it's going to be 130 degrees over 360 times 2 times 3.14. And before we put in that 10 is representing the diameter. So we actually have to cut it in half and put in 5. So plugging in, I'm going to have 130 divided by 360 times 2 times 3.14 times 5, and I got 11.34. And that's going to be the length of that arc. All right, guys, that was a ton of content. All right, absolutely a ton of content, a lot of vocab. So please make sure that you're studying your vocab so that tomorrow we can just jump right in with the new